Previously, you learned about the basics of MongoDB through the Mongo shell. However, in web development, our apps don't usually interact with the database through the shell just like what we did. Commonly, commands go through a layer of abstraction called Object Relational Mapping, or ORM. The idea is we can write complex database queries using object-oriented paradigm of a programming language. In document-based NoSQL databases like MongoDB, this is called Object Document Mapping. In this video, we will convert our MongoDB documents to JavaScript objects using Mongoose JS, an object data model library for MongoDB and Node.js. Before we proceed working, let's first make sure that we have our data in MongoDB. For this video, we will just reuse our data from our previous topic, the UPLB database. If you have deleted your data dump or emptied your database already, I will upload my dump file in this repository. I will also put the link in the description. Just download it as a zip file and use Mongo Restore to put it back in your database. First, let us set up our Mongoose. So I have created here an empty node project. Assuming that you have node and npm working in your devices, let's install it through npm. The command is npm install mongoose -- save. Now, we have installed Mongoose and we have our data in our database. Let's now try to manipulate this data in our node project. To use Mongoose, we have to import this in our project using the command require mongoose. First, we need to connect to our database server. To do that, we write mongoose.connect, and then our Mongoose server is located at port 2701. So we will write MongoDB localhost 27017, and then we will use database UPLB. And then we will also set some configurations inside. Next, we have to interact with our collection. We first have to define our models. Defining our models is like defining our schema. Our JavaScript application cannot directly interact with a MongoDB document. That is why we have to represent them as JavaScript object in the form of these models. So let's create a model for our collection subjects. So we define here a constant subject. Mongoose.model. Our first parameter is subject, and then we write here the fields of our collection. This declaration will look for a collection inside UPLB database with the name subjects. To validate if we are connected, let's try to print our data. Let's say we want to print comsci2. Similarly, we use the find function, but we write it differently here than what we did in Mongo shell. We have here select.find1. This will return one entry. For our parameters, we have here our query. We write this in JSON format similar to our query in Mongo shell. By default, this will return all the fields of our document. But we can also pre-select the fields we want to return. I want to return them all, so I won't specify the fields. The next one, we have here the callback function. This gets executed after the query. We have here two parameters, the error and the results. You may rename this to whatever you like, but they will always come in this position. So first, the error variable will hold the error document just in case this query fails. We use this in error checking. And the result will hold the values returned by the query. For example, comsci2 is not existing in our database. It will not throw an error, instead it will just return an empty array. We can also use regular expressions in our find function. So here, for example, we want to print all CMSC subjects. Notice that I'm not using find1 function. Instead, I'm using the find function because I want to return all the results, not just one. So we have here the regular expression, and this should return an array of results. Now, itry naman natin mag-insert ng data. First, we will define an object. Our fields should be similar to the one we declared earlier. If we added a field here that was not declared, it will be disregarded by Mongoose. So let's try to insert CMSC 123 data structures. This object lives in our code, but this is not yet saved in our database. So to save, we have to invoke the save function. Although this simple save call will proceed, I still recommend to put a callback function for error checking. So let's do that. I put here as parameter a function that checks error. I have here error as parameter, which will hold the error document should this save function fails. So let's print something here. Since we cannot clearly see what is happening under the hood, since most of the things here in ORM is abstracted, this will give us a peace of mind that our data was successfully saved. Let's try to print that. I'm assuming that we have two CMSC 123 in our data. So I'll query them using the find function. So as you may see, we have two CMSC 123 saved, but in different IDs, so they are still distinct. But let's try to edit the second one. In Mongoose, we have different ways on how we can update a document. First, we can use the find function for simple updating. So it's just the same find function, but inside the callback, we will put the modification we want. Let's say I want to change the other CMSC 123 to CMSC 127, file processing and database systems. So let's run that again, and let's print if we have CMSC 127 in our data. The second one kind of uses the same pattern we used in Mongoose Shell. We use the update function. And to update one document, we use subject.update1. The first parameter would be the query, and the second parameter would be the modification. And for the last part, we can put a callback. Again, we have your error, which will hold an error document should this function call fails. And the second parameter, let's call it output. This will not return the updated object. Instead, it will return the status of the update. So let's try to update CMSC 100. Let's change the description to web app development. And let's run it again. We can also update multiple documents at a time using the function update many. So let's try to update all CMSC subjects description again. As you may see in our output, we have successfully changed multiple documents. I'm going to print all our document to see the current status of our data. Subject.find, and then let's run that again. Now what if we want to delete some data? So we have two options. To delete, we can use the delete one to delete one document, and delete many to delete multiple documents. So let's try to delete one entry of chem, let's say chem 100, and let's print our data. Now let's try to delete multiple entries. Let's say we will delete all the CMSC subjects and print our data again. As of now, we have an empty collection since we have deleted all our data. So I'm going to restore it back again using Mongo restore. For this next part, we will talk about controllers and routers. Previously, we have discussed creating a simple server application through Express.js. Now, we wanted to support database CRUD operations in our Express server. We want to request and perform operations in our data from a client through our server. We can do that by integrating our database to our servers. Ideally, we can also write everything in one file, but in building our code base, we want to separate our code into logical blocks for readability and maintainability. So I will introduce to you controllers and routers. A controller contains the business logic of the web application, or the part that deals with handling how the application's data is read, processed, stored, etc. So yung mga operations natin, we place it here in our controllers. And then we also have routers. This is where the path and corresponding HTTP methods of the web application are defined. Additionally, the router matches the path of the web app with the controller function that will handle its incoming messages. So in basic words, sa router, dinedefine natin yung mga path with their HTTP methods, and then we will couple it with our controller to specify what to do in case our server receives such requests. Halimbawa, we define a path for our homepage, so we will access it through our browser, and that is a GET request. Every time we open a URL in our browser, it sends a GET request to a server. So para malaman ng server that it needs to expose this URL to our client for a GET request, we define it in our routers. And paano naman malalaman ng server what to do once it received a GET request in this path? There is where controllers comes in. Controllers dictates what to do when it receives a request to this path. Now let's try to build our architecture. So initially we write everything in one JS file, but we will separate them into logical parts. I will create 3 files, one for our server, one for our routers, and one for our controllers. So for our server, let's use index.js, and I will just configure a very simple Express server. And we will create router.js for our router. Our server needs to know the path it needs to expose, so we will export it and import to our index.js. As you may see, I defined here a slash which indicate our homepage. And for callback, we can define here a function, but we will not do that. Instead, we want to invoke a function in our controller. To do that, we first have to define our controller. Let's say I want to print welcome to our homepage every time a user accesses our homepage. Now, I want to export this and use it in our router. So back to our router, we import controller and we use the function homepage. You can define here multiple paths, and you can also define multiple functions in our controller depending on your design. So if we run this and open our browser, we can see the text we defined in our controller. So what happened is our server looked for the path and invoked the function we defined in our controller. Now that we have our routers and controllers in place, let's now work on integrating our database into this architecture. So what I want to do is I want to access a URL, and I want that page to show me all my data from the database. So let's do that. First, I will declare a path in our router like find all subjects. When I get requests to this path, I want the controller to fetch the data from the database and return it as an array. So let's export a new function in our controller.js called findAllSubjects. As of now, this will produce an error because we haven't defined this function yet. So let's create that function. Going back to our controllers.js, we define export findAllSubjects. You can name this whatever you like, but it has to be of the same name like the one you called in your router para ma-reference niya. And then the structure is just of a typical controller function. And then inside, we will apply our learning from Mongoose. Before we can use Mongoose here, we first have to import it using require. And then of course, we have to connect to our database server. And then we will declare our collection. Now it looks well configured, let's query our data inside the findAllSubjects function. We will just use a simple find function to pull all our data, and instead of printing this in our console, we can send it to our client. Review lang tayo ng lesson from Express. We send our data back using this response object. So it looks good. Let's restart our server. Now let's try to go to the path we defined. Again, accessing this in our browser will invoke a GET request to this path, and since this URL matched the path we defined in our router.js, it will invoke the controller. And inside the body of our controller, it pull out data and send it to our client. So there are a lot of things you can explore and do in our Node.js, MongoDB, and Mongoose integration, but for now, I will not cover them all in this video, but you may explore it on your own.